The wavelength of the monochromatic light from a lamp is to be determined by means of a double-slit interference experiment, which part of the setup is placed in a transparent glass tank as shown in the diagram below. Initially, the glass tank is empty. State and explain what changes, if any, occurs in the pattern of the fringes observed when each of the following changes are made separately. A. Increasing the intensity of the light source incident on the double slits. Now the bright fringes will become brighter. This leads to better contrast between the bright and dark lines. Increasing the distance between the double slit and the screen, the fringe separation will become greater as given by delta y equal to lambda L divided by D. Reducing the intensity incident on one slit of the double slit. Firstly, the bright fringes resulting from the constructive interference are less bright than before. Secondly, the dark fringes are less dark than before because destructive interference is only partial, not complete. This results in fringe pattern with poorer contrast. The light source is replaced with one of white light. The interference formed by a double slit for a green monochromatic light is shown above, and those from a white incident light is given below. So the central will be white, but the rest you'll see a spectrum of colors. If it's a 6-slit grating, then the pattern will be as follows. For zero order, you have a central white fringe. For higher orders, the next few fringes beside the zero order, one will get rainbow fringes. The visible spectrum lining up in the fringe starting from blue on the outer, on the edge nearer the principal axis, ending with red on the edge further away. Since the fringe separation is given by lambda L divided by D, so it's proportional to lambda. The fringes are likely to overlap at higher orders, and one could no longer distinguish one fringe from another. Now a small glass block is placed in front of one of the slits. The optical path length, in terms of number of wavelength, increases in the glass block since light travels slower in glass, so lambda is shorter in glass. The zero order fringe shifts in the direction of the slit covered with the glass block. So everything moves up if the glass block is in front of S1. Both slits are covered with sheets of Polaroid, and in front of one slit the Polaroid is slowly rotated. So starting the polarizing axis of the Polaroids parallel to each other, we'll get fringe pattern of very good contrast, but less intense overall, as the Polaroids would have absorbed some of the light energy. The displacement of the resultant waves is given as follows. So both of them are parallel, so the resultant amplitude is 2A for constructive interference, and one is up and down. It will cancel, so you have a destructive interference. As we rotate one Polaroid, the angle between the polarizing axis of the Polaroids changes, and we will not get complete cancellation for destructive interference. The contrast between the bright and dark fringes gets poorer and poorer until when the polarizing axes of the Polaroids are perpendicular to each other, we will not get any interference pattern. The displacement of resultant waves is given by this expression, so we'll get square root of 2A. That is the resultant amplitude. So when both Polaroids are aligned with the axis parallel, the resultant amplitude is 2A, the intensity is 4I. And you have this pattern of bright, dark, bright, dark, bright. Now when the Polaroids with the axis are perpendicular, then the amplitude is always square root of 2A, and the intensity is 2I. So you get a uniform intensity given by the red line. Further explain what you would observe if the glass tank is now filled with smoke particles. The intensity of the bright fringes may be reduced since some light is scattered by the smoke particles, so the nodal and anti-nodal line may be observable from the top. So we will see these lines. Now if the glass tank is filled with water, then the Light has a lower speed in water, hence the wavelength will be shorter. Therefore, the fringe separation will be narrower, as given by this, since lambda is now smaller.